Yeah, can you see my screen now? Hello, can you see my screen? Hello.
Yes, yes.
Okay, yeah, we'll just start in a minute. Okay, let's start. Okay, good evening, everyone. Can you hear me? Hello, audible? Hello, can you hear me?
Yes, yes.
Okay, you can see also see my screen. Can you see my screen? You can use the chat. We cannot talk. Okay. Yeah, you can. Hello, can you see my screen?
Yes, sir.
Okay, great. Fine. Let's get going. Okay. So, good evening, everyone. So today, so I'm Vijender, and today we'll talk about MLOps for LLM products. Okay. So LLM products again is again applications developed using LLMs. Okay. And today we will what we learn today is what is MLOps and why it matters for LLM applications. Okay. So what are the key components of an LLM deployment pipeline? Okay. And monitoring and maintaining the LLM products in production. Okay. We'll also kind of see a hands-on for a simple LLM application with monitoring. Okay. So that's what we'll cover today. So what is the purpose of MLOps? Okay. So typically, again, I think in the past few days, we have been discussing about models, some ML models and all that. So some agentic AI applications also. So now that suppose you trained your ML model, machine learning model, and you've tested its inference capabilities, right? Inference is when you run the ML model, right? With some inputs, you get some outputs, right? So that is an inference, correct? So even when you use ChatGPT and you ask a question, say, what is the capital of India? That is also inference, right? So it gives a response, and that's the response from the LLM. Now, let's say you build an ML model which does, help you in giving this inference, right? What comes after that, right? Is it enough to build an ML model which gives a response for your queries? Not really, correct? Because what you've completed is only a small part of a much larger journey that will unfold next. Okay. So building the ML model is just a small part of it, and we'll see how small it is. Okay. If you have to make it available for everyone in the world to consume, right? Like for example, ChatGPT is available for everyone to consume in the world, correct? So how is it available? It cannot be on running on local host or just on a local machine, right? It has to be deployed on some server somewhere, and all of us are accessing that model through the publicly available API, correct? So ChatGPT gives us either an API or ChatGPT gives us a web UI where web app where they are using indirectly the API of theirs. Okay. So if you plan to deploy the model in real world applications, there are many additional steps to consider. This is where MLOps becomes essential, helping you transition from model development to a production ready system. Okay. So MLOps will help you to transition from model development to a production ready system. Okay. So because ultimately you need your model to work in production for everyone to access, right? So what is the high level purpose? Okay. Again, this is more like definition is about integrating ML models in real world systems. Okay. It's where machine learning meets software engineering, DevOps, and data engineering. Okay. So earlier we used to have DevOps, correct? I think all of us know about DevOps. Most of us might have heard of DevOps. But what is MLOps, correct? So the MLOps is a combination, right, uh, of software engineering, DevOps, and data engineering, correct? So why do we need all these, right? So we need all these because machine learning as such is not only about writing a standalone application and deploying it, correct? It is also about the software engineering part of it, which is written in Python. It's about taking the data. It's about building a model. It's about deploying the model, right? That's where DevOps comes in, right? And it's also about the data engineering part where we are pulling data from various sources, right? So typically, any machine learning model requires data. That is the basis. Okay. Now, data engineering is that branch of data science where we handle data, right? We pull data from various sources using data pipelines, and then we perform extraction, transformation, loading, or ETL, and then do some pre-processing and exploratory data analysis, and then get the data in the format, do feature engineering, build the model, and all that stuff, correct? So MLOps involves making sure that all of this is working seamlessly, okay? Otherwise, if you are having hundreds and thousands of files, it's difficult to manage them manually by copy pasting them from Google Drive, correct? So the goal of any MLOps solution is to reliably deliver ML driven features. Okay. What are some ML driven features like recommendation engines, fraud detectors, voice assistants, etc. to end users at scale? Okay. So end users should be able to use them at scale, and MLOps should help us get this going. Okay. A key realization is that the ML model or algorithm itself is only a small part of the production ML system. So that's why MLOps is critical, okay, to making sure that whatever you build is available to everyone. Okay. So typically, again, what is the purpose of MLOps, right? So you have a model configuration, right? You have code written in Python. You have data coming from CSV. You have various performance metrics, and you also have the final model, correct? So MLOps is going to make sure that all of these are integrated and working together in a seamless manner to help us build solutions which can be deployed and made accessible to our users at scale. Okay, scale means at a very huge volume of transactions. Okay, now if you see, right, like again, ML code per se, whatever code you write for building that ML model, right, it's just a small part of the whole set of other activities that go into building a ML system in production. Okay, so you have something called data collection, correct? That's a big piece. Data verification is another big piece, right? Feature extraction, another big piece, right? Analysis tools, right? Machine resource management, service infrastructure, monitoring, configuration. So there are a whole bunch of elements involved in this where ML code is just a small part of the whole thing. Okay. So what is the benefits of ML ops? Okay. Why should we learn it? What is the benefits? What are the benefits? Okay. So MLOps seeks to manage this complexity, of all the numerous moving parts. Okay. It manages this complexity by applying reliable software engineering and DevOps practices. Okay. So MLOps does not say it is completely different from DevOps. It incorporates software engineering and DevOps practices to ML systems. Okay. Ensuring that all these components work in concert to deliver value. Okay. So MLOps is like, again, is a set of practices and processes which helps us build and deploy ML systems and models at scale. Okay. So before the advent of mature MLOps, what would happen? Building and updating MLOps was slow and laborious. Okay. Requiring significant resources and cross-team coordination for each new model. Okay. So what was the problems? The problems were it slow time to market. That means it would take weeks or months to deploy a new model due to ad hoc processes and lengthy handoffs. So each team would take time to pass on data. Each team would take time to understand what data is there in which team, and it was very laborious and was taking a lot of time, right? So that was slow time to market. Next is fragile pipelines, correct? So if you don't have strong MLOps, the data pipelines might easily break. Okay, what does the data pipelines break means? Suppose there's an error somewhere, correct, in the data pipeline. What is the data pipeline? For example, suppose you're building a application which is a stock price predictor, right? Now, that the continuous input is from some various APIs or some various databases, you're getting the data. Now, how do you get it? You have a pipeline, data pipeline, which will fetch it through their APIs. Okay. Now, suppose there is some exception, whatever exception it is, and the data pipeline got broken, right? So if you don't have a fault tolerance built in, like you don't have the ability to have an alert mechanism or something like that, it will be like that only, and your model keeps getting the wrong data and your predictions all go wrong. So that's why it's important to have that strong data pipeline where even if it gets broken, it either has a retry mechanism or it has an alert mechanism, right? In either case, it ensures that whatever purpose it is there for is served and the data keeps moving properly. So that's why MLOps brings in that element of surety that every moving part in the entire system is working properly. Okay. So the next thing is scaling issues. Okay. Now, if you don't, without MLOps, for small systems, it will work fine. Okay. But when your systems become big, right? If you don't take care of proper MLOps, then it will start crashing, right? So typically, I don't know how many of you are able to were using Claude. Earlier, if you see Claude used to say that, there is some unexpected error, right? Nowadays it doesn't come, but it used to come like a few months ago, very frequently, saying that this is exceeded the number of concurrent connections, or some kind of errors used to keep coming, but they never come in ChatGPT, right? Because ChatGPT has very solid processes. Of course, now Claude has become very big company. Now they have taken care of all that, but it all comes down due to having scalability and other aspects of caching and all the other things which should be built in. Now, effective ML addresses this issue. MLOps addresses these risks by establishing processes to continuously monitor, evaluate, and improve models after deployment. So it is not just about deployment, but it is also about monitoring, evaluating, and improving the models after deployment. That is extremely important because that is how we make sure that the model is continuously giving us the best results. Okay. So sometimes you will see that even if a model is deployed, it can quickly deteriorate in quality. Okay. So why does a model deteriorate in quality? Because ultimately the quality of a model is based on the quality of the data that it receives. Okay. So over a period of time, if the data on which the model has been trained has become outdated, right? Then the model itself is no use, correct? So model has to be continuously updated, enhanced with the latest data, correct? So what do you mean by the latest data? Basically, we are saying that maybe the demographics of that particular input data, what the model is trained on, has changed, right? Demographics can be age, gender, and all that, right? So if that is changing, then the model needs to be updated and trained again and tested, validated, and then again deployed, correct? So all of this should happen again smoothly and seamlessly without the users getting interrupted. So the whole operations, right, is are taken care of by MLOps. Okay, so that's why it's important. Now, sorry, any question? Is someone talking? Uh, is someone asking a question? Okay. Beyond that, any question? Okay, let's move on. So overview of MLOps. Again, overall MLOps can be thought of as DevOps for ML, but more nuanced. Okay, so it is a set of practices, tools, and team processes that aim to build, deploy, and maintain machine learning models in production reliably and efficiently. This includes collaboration between data scientists and engineers, automation of ML pipelines, okay, and applying the best software practices to ML like testing, version control, continuous integration, and so on. Okay. Now, typically, if you look at why again MLOps is coming into picture, if you suppose there are three users, correct, and each one of them is trying to do different kind of activities, correct. One of them wants to do pre-processing, one of them wants to do label transformation, one of them wants to do feature engineering, and all of them are working on the same model, but they are working on different, the same files. How do you provide them access to it, right? So you have to provide a seamless way so that all of them are able to access the data and able to manipulate the data. Okay. So by putting the right infrastructure and workflow in place, MLOps enables us to iterate quickly on models while keeping them running stably in a live environment. Okay. So we'll see how ML systems differ from traditional software and life cycle of ML system design. So so I think we'll kind of maybe skip some of these. Okay, MLOps versus DevOps and traditional software systems. I think this is important. You should know. So quite a lot of times people get asked what is the difference between DevOps and MLOps, correct? So building and deploying ML systems is in many ways an extension of traditional software engineering, but there are important differences. Okay. So it is not completely new. MLOps is not completely new. It's built on top of DevOps and traditional software engineering. So development operations or DevOps, okay, refers to the best practices that software teams use to shorten the development cycles, maintain quality through continuous integration, CI/CD, and reliably operate services. That is DevOps. This is a classic thing which has been there for a lot of time. Now, MLOps borrows these principles but extends them to deal with the unique challenges of ML. Okay, so what are the unique challenges of ML? We will explore this. Okay, so um, the experimental development versus deterministic development. Okay, so while traditional software is typically a deterministic process, okay, the process in ML development is highly experimental and data driven. Okay, so what does it mean? Deterministic process means it is highly sure that if I do like this, I will get this. Okay, it's deterministic. There's not too much of ambiguity or variation. But in ML, the process is highly experimental and data driven. Why is it? Because you're trying different kind of models, you're trying out different types of data, different type of features, and you're trying to see which one gives you the best results. Correct? So it's a bit highly experimental. Okay, so you try multiple algorithms, features, and hyperparameters to find what works best. So this is what is the characteristic of ML development, and that is how it is different from traditional software development. Okay, now the code itself is not buggy. Okay, the code may not be buggy, but the model might simply not be accurate enough to be deployed. So the model that you're considering for the particular problem statement, right? For example, stock price prediction, you picked up some model. Now maybe that model is not the best model for that. So you try a different model, right? Or maybe the features you selected are not ideal. So you try a different set of features. The data itself is not correct. You try different kind of, or you're replacing the data, right? Suppose you have null values. How are you replacing the data, right? So all that are various iterations that you take up to kind of get the best results. Okay. So that's why it is a experimental approach, experimental and data driven, whereas traditional software development is deterministic. Okay, so just make note of these terms. Thus, there is an added challenge of tracking experiments, handling stochastic results to ensure reproducibility of results at later stages if needed. Now, what you learn again, I think this is okay. So in today's session, I'll also show you one quick demo app where we are talking about how we build observability. Okay, so we'll come to that later. First is let's talk about a problem statement. Okay. So imagine the scenario where you built an amazing chatbot using GPT or Gemini API during a hackathon. Okay. Now it works perfectly on your laptop. Okay. But the point is, this is an LLM application. Okay. So any chatbot built using GPT or Gemini API is a LLM application. Correct. So how do you make it available 24 by 7 to users? Correct. So ultimately, there's no fun in saying you build this application. You need to make sure your users are using it. Right, and 24 by 7. What if 1,000 users try to use it simultaneously, right? If 1,000 users hit the same endpoint at the same time, can it respond to them? Yes or no? Correct. How do you know if it's giving wrong answers, right? So now if you have thousands of, see, if you have 10 requests, you can monitor them, each one of them one by one. But in production, people can ask different questions and your model can give different answers. And how do you know if it is giving wrong answers, right? Because end of the day, certain users can make decisions based on what your model is giving as an output. Correct. So stock price prediction, for example, if it gives wrong stock prices, then maybe they're losing money. So you have to make sure that it gives the right output, right? And what happens when the API bill crosses 50,000, right? So you're seeing that due to a spike, the whole system has suddenly, scaled enormously, and because of which your bill is rising. What do you do, right? You need to set up alerts, right? You need to make sure that if there are some checks and balances in place, wherein if it reaches 20%, 25%, you get an alert, right? Billing alerts. How do you update it without breaking everything, correct? So typically, again, this is something that's there in DevOps also, correct? You need to make sure that whatever deployments you're doing are not impacting your users. It goes through seamlessly without people noticing it much. Okay. Now this is where ML comes in, MLOps. So MLOps is basically ML, machine learning plus DevOps plus data engineering. So these three combined together is MLOps. Okay. So you also consider the machine learning aspect of it, you consider DevOps aspect of it, and you also consider the data engineering aspect of it. Okay. So if you look at traditional software development, it was more about writing code, testing it, deploying it, and monitoring it. Okay. But in LLM, you're saying you select a model, you do prompt engineering, you build the app. Okay. All this is done in local. And then you deploy the app, you monitor the responses, you track the costs, you do version prompts, handle failures, and then scale the infrastructure. Okay. So MLOps basically handles everything after the build app stage. Okay. So that's what the MLOps is for. Now, why MLOps is critical for LLMs? Okay, so unique challenges with LLM products are that they are non-deterministic outputs. Okay, so LLMs basically can give different outputs for same input. Okay, again, there are additional things like temperature and all which impact how they give, but generally the tendency is not every time you'll get the same response. Okay, they have high costs. API calls cost money per token. Okay, the latency issues. So if the LLM takes a lot of time, users will not wait. Okay. And quality drift, model updates can break your app, right? So if a model has updated its logic, it can break your app because you're entirely dependent on the model, right? Quality and then safety concerns, right? So harmful or biased outputs damage reputation. Okay. So without MLOps, your app crashes, cost spiral, users get bad response. And that's where you need MLOps to make sure that all of these issues, whatever are there, are handled in a very seamless manner using MLOps. Okay. So let's talk about the MLOps life cycle for LLMs. Okay. So till here, any questions, anyone? If anybody has any questions, we can take on quick questions or we can go on. Okay, so there are six key stages. So you can put it on the chat if you have any questions. Okay, so there are six stages, key stages for the LLMs. Okay, one is uh, development, experimentation, deployment, monitoring, maintenance, and scaling. Okay, so development is where you are doing prompt engineering, model selection, and building the actual model, right? And then experimentation is testing different prompts, correct? And what are different models that you're using for the purpose of the LLM application. Deployment is where you are saying, okay, I already done. I have experimented. I've checked the inference. Everything is looking great, working fine in the local. Now I want to make it available for everybody. That's deployment. Monitoring is, okay, once you made it live for everyone, you have to monitor it continuously to make sure that you're tracking the performance. That means how fast is the are the responses, what are the costs, are there any errors, right? So you have all these monitoring aspects. So you have various monitoring tools. Okay. So some of the monitoring tools you have like Prometheus and, you have generally again for software as such, Datadog, is one such, application performance monitoring tools like, they're called observability tools, right? And again, you'll have observability in various stacks. So monitoring is also important. So maintenance is also important to make sure that if you want any changes in the model, it works smoothly. Okay, so you cannot build a model and just deploy it once. You want to be able to make sure that if the model requires an update, it goes through smoothly. So scaling is making sure that more users can be supported by the application. Okay, so then let's go through each of the stages one by one. Okay, so in the stage one, what we're saying is model selection and prompt engineering. Okay, so here the key decision is again, this is we are going step by step from this one. Okay, model prompt engineering and model selection. Okay, step one, development. Okay, so in development we are saying which model do we want to go with? Okay, do we want to go with GPT-4, Gemini, Llama, or Mistral? Okay, so what are the decisions based on cost versus performance? Okay, so some models are very powerful, some models are not so powerful. Okay, so if you see, I mean, typically, you can see OpenAI cost chart. I think recently they have a price chart. I'll just show you this. Uh, there's the pricing, API pricing. Yeah, so if you can see, right, GPT 4.1 fine tuning price again. This is a fine tuning. Uh, yeah, I think these are the yeah, input, right? So if you see GPT 5.1, the input is $1.25 per 1 million tokens. GPT-5 mini is just $0.25 per 1 million tokens. Okay. So you see the difference. Okay. So it's five times more. Okay. So GPT-5 Nano is 0.05. It's still smaller. GPT-5 Pro is $15, right? You see this? So each of these models have different costs, and you should be selecting the model very carefully, and that is those are the decisions. And performance also is a function of what kind of model you select. Very if it costs more, obviously performance will be better. Okay. So the other decisions you also have to take is, do you want to go for an API or you want to go for a self-hosted model? Okay. So API is where you call the API of Open ChatGPT, Gemini, or something, and self-hosted is you are taking that open source model and deploying it on your own machine and then making inference out of that. Okay. So each one of these options have their own trade-offs, correct? So if you're using API from an MLOps perspective, it's easy because you just call the API and it's going to take care of scaling at the API side. So suppose you have 1,000 requests, you can make 1,000 requests to the API, and it's a headache of ChatGPT to how they scale their requests servers. Okay, but if you're self-hosting it, then you have to make sure that you have the right infrastructure or machines to host your model. You should make sure that it scales, and you should take care of all those other additional things like security and privacy, data privacy, and all that. Okay, so these are very important decisions when you're looking at a model selection, and that's why they are important from an MLOps perspective, because if you made a bad decision in the start, right? Suppose you just assume that it's easy to do self-hosted, right? Client said, I want something. You just said, let's do self-hosted without thinking through on what are the ramifications or the impacts downstream, correct? Then it's going to be very painful, because after 3 months, when the model is ready for deployment and you want to go for it, then it becomes extremely expensive. And then you cannot go to the client and say, sorry, we spent 3 months, but now we realize that it is too expensive to host your own model because we need GPUs, correct? You cannot deploy these models on your own thing. Even Llama 4, if you're looking at even 7 billion, you cannot run it on your local small server. Even T2X large cannot host it. You need GPU machines, okay? And they can be very expensive. So it's very important at the first stage, and that's why an MLOps engineer should also be looped in when these decisions are being made at the model selection and stage itself of the entire process. Okay, ML building process. Now, what are the best prompt engineering best practices? So version control your prompts, test with diverse inputs, document expected. These are anyway for prompt engineering. Now let's look at this next stage of the MLOps operation, right? So experimentation and validation, machine learning bit development process, which is experimentation and evaluation. Okay. Um, so how to know which model or prompt works best? Okay, prompt or model works best. So we have certain metrics. Okay, so every time, suppose you want to evaluate if certain thing is working properly or not, you have some metrics. Okay, so what are the evaluation metrics for LLMs? Okay, so you have the response quality, which is either uh, evaluated on the basis. So which model do you pick? Correct. So now that you identify that you want to go for an on-prem API or on-prem, and you make those decisions, the next thing is you keep evaluating or experimenting or evaluating until you find out what is the best model and what is the best way to use it. So you have various evaluation metrics. So response quality is one thing, and you can measure it by using human evaluation where humans evaluate it, or you can have LLM as a judge. LLM as a judge means basically you have another LLM which is evaluating this LLM in terms of how it's performing, correct? So you provided various inputs or prompts in terms of what parameters it should evaluate, and it will tell you. The next thing is latency. Latency is the amount of time it takes to process a response, correct? So it is the amount of time it is going to take for a user to get a response from the application. So imagine if you're working on going to Amazon.com and it takes like 10 seconds to just load the page. Do you want to go and shop there? Not really. Or imagine if Gmail loads and it takes 10 seconds to load the whole page. Would you like it? No, correct? Similarly, if you're building an application in Gmail where you're saying every email which comes, correct, I automatically classify it as whether it's a personal email or an office email, correct? And imagine if it takes like 20 seconds, the email has come in just 20 seconds, you still not updated the status. Would you like to use it? Not really, correct? So you have an ML algorithm out there which is automatically classifying the email, but if it takes too long, then users will not be interested in that. So that's extremely important to consider latency. Correct. Next is your cost per query. Okay. So cost for LLMs, now since we are building LLM applications, the cost for LLMs is a function of input tokens and output tokens. Okay. So like we saw on the ChatGPT page over here, you might have seen here, the price here is mentioned in input to as $1.25 per 1 million tokens. Okay. And output is $10 per 1 million tokens. Okay. You can see it is huge, right? So again, here also GPT-5 Pro, 10 million, $120 for 1 million tokens. But for GPT-5 Mini, it's $2 per 1 million tokens. Okay. And $0.4 for 1 million tokens for GPT-5 Nano. Okay. Now, if you see, each of these models will have its own capabilities, correct? So again, when you build applications using these models, they're all LLM applications, correct? But you must be extremely careful about their prices. Before using them, you have to be careful about which model to use from the perspective of these four parameters. Extremely important. Response quality, latency, cost per quality, and success rate. Okay. So what percentage of properly formatted responses are they giving back to you? So generally, if you go for a high quality model, you will try to get the very high quality success and a high quality output. Okay. So that's how it generally works. But again, for a high quality model, again, the cost is also high quality. Okay. You might have seen this is $10, very high, right? And this is $120, right? Of course, the smartest and the most precise model, correct? Now, these are just APIs here. Most of them are APIs. But what if you wanted to deploy them, right? Now, again, there also you will have open source models like Llama 4. And, in that also there are various number of parameters, 3 billion, 7 billion, 175 billion, and so on and so forth. So the bigger the model you use, the better it will give. But then you'll have to take care of how you're going to take care of the ML part of it. So during the initial stages, stage one and stage two, also you should be continuously conscious about MLOps. How are you eventually going to deploy it? How are you going to make sure that even if it is working here in local, it works well in production, considering these four aspects? Extremely important. Okay. So an MLOps person should always be looped in. That's why an MLOps person is not someone like DevOps who only does deployment of the node application or Java application. An MLOps engineer should also have an idea of ML. How does it work? What are the various stages? At various stages, what decisions need to be made? Okay. Now, some of the inputs for this, the tools that are used by MLOps professionals are Langsmith. So Langsmith is a tool which is basically used for observability. Okay, is observability for Lang graph. You can see that Langsmith observability. So whatever agents you build using Lang chain or Lang graph, okay, Langsmith gives you that observability. How you will gives complete visibility to agent behavior with tracing, real-time monitoring, alerting, and high-level insights into usage. Okay, so this is how it tells you whatever agent you build, what all are happening. Okay, so a significant part of MLOps is observability also. Okay, so you'll see find failures fast with agent tracing, correct? Monitor what matters to the business, track it, correct? Discover usage patterns and issues automatically. So a good part of MLOps is also providing your business, your development team with statistics and metrics about observability or usage. Um, then see again, you also have others like weights and biases and ML flow. Okay, these are also additional tools. Now, the third stage of MLOps in building ML machine learning, applications is LLM applications is deployment architecture. Okay, so how are you planning to deploy it? Okay, now if you see any LLM application will not only contain backend. Like a lot of people think that LLM application means just to call a ChatGPT API or deploy it in Olama on your local and make a call and you get a response and that's it, right? So that is correct in a way. You have a backend because the backend is what really goes and makes a call to the LLM, right? API or the model in your local. But the point is, you cannot just simply give that to users. Correct? You cannot simply give that to users and tell them to use the backend API. So what you need is a front end, okay, and you need a backend API, and the backend API will be a wrapper on top of your LLM, correct? And the backend API will also make calls to database, correct? So typically you will have a three-tier architecture, correct? Three-tier architecture is client side, which is the React or Streamlit, okay? React is written in Node and JavaScript. React is written in JavaScript. Streamlit again is in Python. That's for front-end technologies. Backend, you can have Fast API or Flask. So majority of the industry nowadays is moving towards Fast API. So that's where you should go. And you should figure out how you deploy it also. I'll cover in subsequent slides how you will deploy it. Okay. LLM provider is again OpenAI or Gemini. Okay, whatever API you want to use. And again, you have database. So database can be any database of your choice. You can use vector databases or you can use traditional NoSQL databases. Okay. So in terms of deployment platforms, what are the deployment platforms? I said for Streamlit, you can use Streamlit Cloud. Okay. And for models, you can use Hugging Face Spaces. Hugging Face Spaces is the where Hugging Face gives you the ability to deploy the models. It's called Spaces. Okay, so here you can go ahead and deploy your models. Next is in production. If you want to deploy a backend, you can use Railway. You can use Render. Render is the best. Okay, just to connect it with your GitHub and directly it will render deploy it. Okay, so if you see Render, this is Render. Directly it will go and deploy. It's for free. But only problem with Render is you will have cold start. Okay. So railway is something that has come recently. I've not used it much, but railway is also another infrastructure platform for backend. Okay. I think they allow in front end also, but typically I think mostly they're backend. But you can have a look at it. Again, AWS and Google Cloud are anyhow there, but these are, they will charge you for that. Correct. In AWS, you can use a free tier, but the point is you have to put up your spin up your EC2 server and then configure the ports and set up security groups and all those things you have to do. So much of hard work. Whereas in Render, you directly connect with the GitHub and it will work. That's it. Smooth. Okay. So advanced is basically if you want to use, you can use Kubernetes with auto scaling. Okay. For basically containerizing your application and then using Kubernetes for managing your Docker containers. But that's very advanced. Mostly, I would not recommend that. If you are starting out early, your deployment should be focused on either Streamlit Cloud or Hugging Face Spaces or Render. That's it. You don't need anything else. And of course, if you want to deploy your React application, you can use Vercel. Okay. So that's another thing. So Vercel is extremely brilliant with respect to front-end React deployment. Very easy. Here also you just connect your front-end connect with your GitHub and it will deploy. Okay, one click deploys. So simple and straightforward. Now let's move on to the next one, which is API design for LLM products. Okay, so now an MLOps engineer should also know how things work, right? So typically, again, irrespective of whether we're using MLOps or whatever, the API structure and API things don't change. They're still the same because under the API, we are making some calls to the LLM API or anything else, correct? So typically, like this is like any other REST API, you have /API/chat for the chatbot. You're sending a user ID message and session ID, and response you're getting as response tokens used, latency, and model name, correct? So nothing majorly change in this, right? The only reason why we send the response metadata is because we want to do monitoring and debugging. So that's why it's important to send the response back. Next stage is monitoring, correct? So monitoring, like I mentioned for Datadog or even Langsmith, right, is you should be able to know what are the performance metrics, cost and quality, correct? So I already mentioned these parameters early. So performance metrics is average response time. How fast is the response coming from the model, right? When I ask for a request, right? Next is P95 and P99 latency, right? So these are the 99 percentile 95 percentile and 99 percentile response that we are getting from the model. Okay. So error rate, what are the error rates that we are getting? We should also see those. Cost metrics are basically how many tokens are consumed. Okay, so here I'll just show you in our application here we just built. Here you can actually see, I'll show you what these requests that are being made. But you can see that for this particular request, 11 tokens are used with the latency of 1.2 seconds, 1252 milliseconds, correct? So it's 1.2 seconds. So the input length that I've given is 2 characters, output length is 36 characters. Okay. Now, user ID and all that is there. So what is the cost involved? 0.0003, correct? So in INR, right? So basically, every request I'm able to track what is the impact of that particular request that came to my system, so that if I'm seeing a red flag, for example, I'm seeing this request here, okay? This request has come test to user ID, right? And input is 70, output is 14,985, correct? So let's say it was by accident. So I didn't intend it. Suppose the LLM is giving that 14,985. I don't want it. I should be able to immediately catch it and fix it. Correct? Because if you can see clearly, the cost is very high, 0.0769 rupees. That is nearly zero point 0.1 rupees. Correct? For just one query. Correct? So imagine you are getting 100 queries like this, roughly it will be like 10 rupees or something, right? And imagine if it is thousands and thousands of requests, then your cost is going to go very high. So that's why you must be able to have observability. Okay. Next is again cost metrics I've already shown you. Then quality metrics, user feedback, thumbs up, down, response length distribution, and refusal rate. Okay, so you should again monitoring is important. We won't get into all those details. Next is monitoring tools and dashboards. Again, here I gave some examples of what are the monitoring tools and dashboards. Langsmith I already showed you, right? Over here, this is Langsmith. This is LangChain. Again, Langsmith is a part of LangChain only, right? It's from them only. So LangChain is basically the framework for building agentic AI applications. LangGraph is also used for building the graph-based agentic AI applications. And Langsmith is observability for all the agentic AI applications built using that platform. So yeah. Next we have Helicon for LLM observability and caching. Okay. We have Phoenix for open source LLM observability, and Grafana, Prometheus, and PostgreSQL I've already told you before. Now, what does a good dashboard show? It shows real-time request rate. Okay, what is happening in real time? I just got a request now, it will be able to tell me. Okay, so we'll actually run a demo application. I'll show you how we can get to know in real time. It is not using a professional dashboard, but it's a rough, crude dashboard which helps us understand what kind of requests we are getting. Okay, so what is the cost burn rate? What are the error alerts? And what is the sample bad responses? So should be these all should be shown from a good dashboard. Now, the next thing is stage five of the entire MLOps development process is error handling and the reliability. Okay, so what are the most frequently occurring errors, right? API timeouts, correct? So suppose you made a request and it takes a lot of time for it to respond back. Okay, so that is basically API timeout. And what is the solution for that? A retry with exponential back off. Okay, so it keeps trying for a certain point, waits, and then tries retry after a certain point. That's one. Next is rate limits. So you queue the requests, right, and use multiple keys. Okay, if there are rate limits set. And next is context length exceeded. So every LLM has a context length. So if you exceed the context length, then truncate it and summarize. Okay. But if you don't know from the observability that the context length has exceeded, then you will get some inadequate result, which may not be appropriate. Correct. So that's why it's important to have that. Harmful outputs. So if you are figuring out that your MLOps pipeline is demonstrating harmful output, then you do content filtering. Okay. Format errors. So output parsing with validation. So you again, whatever it comes out of the LLM, you parse it and you perform validation so that you give the best output. The next thing is cost optimization strategies. I think we can talk about this. So cost optimization strategy is how do you reduce your LLM bill again for smaller models. Again, this is more to do with how you optimize your cost. I don't know if it will be required here, but still pretty much I'll just quickly touch it. Use smaller models when possible, implement caching. Okay. So one of the things about MLOps is also you have to figure out how you are planning to cache your data. So this is a very important thing because in LLMs, if you hit the same query, like for example, what is the capital of India? If you hit 10 times also, you'll get the same response, correct? So if you rather cache the query, the request and the response payloads, then you can reuse them if you are getting the same request going forward. Okay, so that's an important aspect. Next is prompt optimization. Shorter prompts, lower costs, remove unnecessarily examples, right? So how do you reduce the prompt size so that you can reduce your cost? And last but not the least, check token limits, right? So that even if you are by mistake, suppose I'm getting a response over here. If I'm getting like 70,000, 14,000, right? Then it's a limit, right? You need to that will help you prevent unnecessary costs. Okay. Now, the last stage, like stage six, is basically scaling strategies. Okay. So when your app becomes popular, right, like it becomes, it has become viral, everybody wants to use their application, then you will have to take care of horizontal scaling and vertical scaling. Okay. So horizontal scaling is basically multiple AI, multiple servers you can keep. Okay. You have instead of one server serving the request, you have multiple servers serving the requests, and each server is distributed the load. Suppose you get 100 requests, then great, one server can do. Suppose you get 1000 requests, then suppose you have 10 machines, each of those 10 servers will get 100 requests each, correct? So that is the concept of horizontal scaling. And horizontal scaling will help to expand the scalability of the application. Vertical scaling, on the other hand, you have one machine which can handle 100 requests. Suppose 1000 requests come in, what do? You don't put 10 different machines. You increase the capability or the capacity of that single one machine so that it can handle 100 requests concurrently, correct? So you do that by increasing the memory, increasing the RAM, increasing whatever, the resources of that particular machine. Okay. So that is called vertical scaling. Okay. Now you also do another scaling strategy called smart routing. Okay. So smart routing basically says if you have easy queries, then send them to the small model. Okay. So don't use the same model for all the queries. Okay. If you have a easy query, send to a small model because your cost will be reduced. You can easily answer it. If you have a really complex query, then you use the large model. Okay. So that way you are kind of intelligently reducing the cost. Okay. Asynchronous processing for non-urgent tasks. Okay. Next thing is version control and CI/CD for LLMs. Okay. Now one thing is important about version control, right? And again, this holds true for again even for traditional software development. You need to make sure that, of course, you'll be having GitHub and all that for your code and all that. But typically, we also say for your version prompt templates, you need to have your own Git version controls because you've been trying out various things and you want to make sure that you have a track of what all you have tried. What are the various model configurations that you have tried? What are the evaluation data sets that you have tried, and what are the deployment scripts as well. So all of this you should be putting it in version control so that you can manage it and access it later. Now, a simple CI/CD pipeline, right? Now, CI/CD pipeline stands for continuous integration and continuous deployment. Okay. So, what does it consist of? Typically, we push code to GitHub. Okay. So, when you push code to GitHub, okay, this is a typical CI/CD pipeline flow. But for those who are new, what happens is when you push the code to GitHub, right? It automatically triggers test cases. Okay. So the test cases are automatically run, and those test cases run on the code to make sure that all the logic is passed. Correct. Now, if the test case passed, then it goes to deployment to staging. Okay. And once it goes to staging, then a manual approval is required saying that, okay, I'm good to go. Let's push it to production. So when you give the approval, it deploys to production and boom, it goes into production. And typically you can use GitHub Actions, GitLab, and GitLab CI and Jenkins for taking care of this. So what is the benefit of doing this CI/CD pipeline? So the benefit is that whatever code you have, if you want to go to production, you should have that confidence that the code which you are pushing into production will always work. Correct. So how do you make sure? Because in your local, it will work. In your development also it will work because your QA, and when you're handing it over to QA also it will work because they're testing it. But when it goes to production, you want to make sure everything works smoothly like how it was working in your UAT, user acceptance testing. Correct. So that's why you have these test cases. So unit test cases are there which will continuously run, and all of them should pass. Then only the code will go to staging area, and from there you will approve it and goes to production. Okay. So because the number of code, sometimes the code that you write is very large. You have huge amounts of code, huge number of files. You cannot monitor all the files, and you have big teams, like, so you cannot manually review everything. So you should have these processes in place. Now, what are the safety and security and safety considerations? So some of the considerations you should take care as an MLOps engineering is how do you manage your API keys? Okay. So one of the things you should also tell, and you should, part of your responsibility is to make sure you're using .env files. So typically, if you look at this is a .env file over here. Okay. Typically, sometimes what people do is they take this API key and put it in the code directly. Okay. .app.py. They directly put it in that. Okay. Or sometimes what they do is they push this .env also to the GitHub. Okay. So the moment you put it to GitHub, it will flag in the internet. It will completely flag and it will tell you that your key has been compromised. You'll get an email from GitHub automatically. Okay. So what is the solution? So you don't put the app.env completely. You just put enter your API code over here, something like that. Okay. And then you will create .env underscore template so that you can copy that into .env and then update your API key. Okay. So next is use environment variables always. Rotate the keys regularly. So even if you have any environment variables, rotate the keys. Okay. Now input validation. Of course, this is everybody knows. Sanitize user inputs and prevent prompt injection. Okay. Output filtering, anyhow, we saw. Check for PII leakage. PII is personally identifiable information. Okay. Check for this PII data. Rate limiting is again, prevent abuse, and you also have per user quotas. Okay. So you have to make sure all these are taken care of so that your system is not abused. Real world MLOps stack is basically, again, you can have model as Gemini Pro, backend as Fast API on Railway or Render, database consisting of PostgreSQL, monitoring using Helicon, okay, caching using Redis, and logging using BetaStack. Okay. So again, we don't have to worry about monthly cost here. So what I'll do is we'll do a demo app. Okay. If you want, people can also take the code from here. Okay, I'm just putting it on the over here. So what this demo app is basically doing, again, in the interest of time, I don't think you can actually run it. So in this app, what we are trying to do is we are in the .env we are declaring the Gemini API key, and then the app.py we are creating two endpoints. One is called slash chat. Okay, this is the fast API endpoint. Okay, slash chat is one endpoint, and the other one is slash metrics. Okay, so slash chat is taking a request, a user request of a chat, and it gives a response. Okay, so for example, if you see here, you can see that when I run this particular file, right, like a test underscore API, test underscore API is going to consist of two requests which are going to slash chat. Okay, so I'm making two local requests to slash chat with a JSON payload, and I'm trying to get the response. Okay, one is a short request saying hi, and other one is a long request. Okay, so the short request of hi obviously is will get a short response, and the long request explain the architecture of a production ML system with all its components. This is a long response, correct? So I want to run this and make a call to the slash chat endpoint and see what the response is. So when I run it over here in the local, you can see that it's responding back with all the data, correct? So the short response says that, hi, and it gives the response immediately, and the long response gives a very long output. So typically when we run this in terms of observability, you can see that when I run this, right, the recent requests, we can see these are the last two recent requests that I have. So the input length is 2. When I said hi, the input is 2, correct? The output length is 36, right? It says hi, how are you, and whatever, right? And you see the 11 tokens are used. Okay, and the latency is 1.148 seconds. The cost is 0.0003 0003 INR. In case of the long request, the input is 70, output is 18,000. So it costs a lot more, 0.086 rupees. Okay, and you also see that the latency is 34 seconds, very long time, correct? Because it is getting a lot of tokens for us, and it is doing a lot of analysis under the hood. So it's doing a lot of analysis, so that's why it's taking time. So that is something about observability at a very basic level, correct? But some of these tools like Langsmith and Datadog and all these, they will give you very detailed kind of analytics. If you see on the right side, right, they'll give you a lot of detailed analytics, and those are the observability tools that you need to use. Okay, so this is it at a high level. Any questions? Anyone? Okay. Okay. Thanks everyone. Thanks for joining. Did Data Valley team any questions? Yeah, PPT. I think I'll share it with the Data Valley team. Should I share it here, or will you share it?
You can share it here.
Please share it with us. Maybe we'll just add some more points if needed and all for
Okay.
different topics.
Okay, sounds good.
Thank
So
you.
let me, I'll share with the Data Valley team, and they will share it with you, please. Okay. Navya? Yeah. Okay. Thank you. Once again, I'll just put a PPT will be shared by the Data Valley team. Yeah. With the participants. Okay. Thank you. Thanks everyone. Take care.